You ready? Let's learn some math. Math, 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 math. Math, 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 math. Math, 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 math.
Come, take a journey with us each Monday from 5:30 p.m. on ABS TV. Let's get to the heart of the matter. Math matters. Welcome back to another episode of Math Matters. I'm your presenter, Mrs. Tisha Hughes Thornhill, and today we are going to take a look at matrices. But, as custom, we will be going over the challenge question from the previous week. Last week's challenge question reads, the diagram below, not drawn to scale, shows WXY and VYZ are right-angled triangles. Angle WXY equals 40 degrees and WX equals 10 centimeters. VZ equals 8 centimeters and XZ equals 15 centimeters. Calculate giving your answer correct to one decimal place. First, finding the length of XY, then the size of angle VZY. So let's focus on the first part, the length of XY. So first, we would begin by identifying the side XY. And there we have it. So we are now responsible for finding that measurement. By isolating just that portion that we will need, we now have a right-angled triangle. So given the 40 degrees angle, first thing we're going to do is to label our sides. We have the opposite, remembering that the opposite is the side that is facing the angle. The adjacent, which is the side next to the angle. And the hypotenuse, which is identified as the longest side, or can be identified also by the side facing the 90-degree angle. So we'll have to remember our trig ratios, sine, cosine, and tangent. Now, XY is the adjacent, and 10 centimeters is our hypotenuse. So which of the three ratios talk about adjacent and hypotenuse? Of course, that's the cosine angle. And so we are going to be using, the cosine ratio, which is the adjacent over hypotenuse. At this time, we are going to substitute the values into our ratio. And so our angle is 40 degrees, so we'll have cosine 40 is equal to the adjacent, which we do not know, and so we'll call it XY, and that is over or divided by the hypotenuse, which is 10 centimeters. Now we have our value substituted. We are going to cross multiply, and so that we can have XY on one side of the equal sign and everything else on the other side of the equal sign. So we are solving for XY. When we cross multiply, XY is equal to 10 cosine 40. And so we can just type that into our calculators, and we are going to get an approximate length of 7.66 centimeters. So it is advised that when you find measurements, because this is not just a single part question, we most likely will need 7.66 for future calculations. And so we would insert that into onto our diagram. Okay? Part 2. the size of angle VZY. Now, where is VZY? The angle is going to be located at the middle letter, which is Z, and so the angle would be right there at Z, which we would have labeled theta. We'd also need another side, because if we examine the diagram we have here, we only have 8 centimeters and theta that would even be useful to our computation. And so we will have to find the length of YZ, and this side makes the most sense because we already have the entire length of XZ, which is 15 centimeters, and we also have XY, which we just found, which is 7.66 centimeters. And so in order to find YZ, we would just do a subtraction, 15 centimeters minus 7.66, and that gives us 7.34 centimeters. So now we have the portion of the diagram that is relevant to this part of the question. We have here 2 sides and an angle. And so again, we will have to name or label our sides: opposite, adjacent, and hypotenuse. And we'll have to also keep in mind our 3 trig ratios, which are sine, cosine, and tangent. And yet again, cosine is going to be the ratio that we will utilize in order to answer this portion of the question. And that is because we have the adjacent and we have the hypotenuse, and the angle is what we would need to find. And so we just remind ourselves of the ratio, and we are going to substitute in the values. So theta will remain because we don't have that value yet, but our adjacent is going to be 7.34, and our hypotenuse is going to be 8 centimeters. And so we will show our division just this, just substituting in the values. As hopefully we would have remembered, in order for us to find an angle, we would need to use the inverse of the ratio. And so theta is going to be equal to the inverse or cosine inverse of the fraction that we would have just found. So in this case, 7.34 divided by 8. And of course, we would just utilize our calculators to come to our answer. And usually on your calculator, in order to access the inverse function, we would have to select shift, or some calculators have a second function button. So it just depends on your specific calculator, but you would have to access the cosine inverse function. And when we do that calculation, we get approximately 23.4 degrees. Thank you so much to all who continue to email their submissions. Before we dive into our lesson on matrices, let's hear a word from our sponsor.
The Board of Education is responsible for the funding of scholarships, awards, and bursaries within Antigua and Barbuda. In keeping with our mandate, interested individuals who are citizens or nationals of Antigua and Barbuda are invited to apply. Application forms are available online at www.abboardofelucation.com and should be completed and submitted on or before the last working day in April of each year. Scholarships are available for those wishing to pursue an associate's, bachelor's, or master's degree locally, regionally, and internationally. Individuals reading for PhDs are also supported. We are the Board of Education. For more information, visit our website at www.abboardofelucation.com or call us today at 463-9025, 463-9026, 463-9027, or 463-9028.
Welcome back. Now let's take a look at matrices and where we can find them. Just a note, when I say matrix, that is singular, and when I say matrices, that is plural. So when I say matrix or matrices, I'm not necessarily referring to the popular movie, The Matrix, though the concept may have been integrated somehow. So let's take a look at some real-life examples of matrices. Matrices are used in geology to conduct seismic surveys. They are used to create graphs, statistics, calculate, and conduct scientific studies and research in a variety of subjects. Matrices are also used to represent real-world statistics such as population, infant mortality rate, and so on. By definition, a matrix is a rectangular array of numbers or other mathematical objects. Here, we have some examples of arrays we may see regularly. We have a case of water, we have cupcakes, we have a chocolate bar, and we even have a parking lot. So these are just some examples of arrays that we may see, more regular than others. The image of the National Housing Development in Painters is also a great example of a matrix array. In this case, a matrix array of houses. In hospitals, medical imaging, CAT scans, and MRIs use matrices to operate. Did you know that? I don't think I did, but I know now. There are many professional fields and organizations who use or rely on matrices. For example, IT organizations use matrices to track user information, and other professions like electricians and engineers all benefit from matrices. What is a matrix? So in mathematics, a matrix is an array of numbers, as we previously would have said. Generally, these numbers are enclosed in squared or curved brackets. So let's take a look at what one would look like. Here is an example of a matrix. When reading matrices, we read from left to right, because that's how we naturally read, right? And we read in the order of the rows. And so we would read this particular matrix as 1, 2, 3, 4, 5, 6. And so in row 1, because now we also identify matrices by their order. So row 1 would be 1, 2, 3. Row 2 would be 4, 5, 6. And then the columns go vertically. And so 1 and 4 would be column 1. 2, 5 would be column 2. And 3, 6 would be column 3. So we can say, or we would say, that the order of the matrix is a 2 by 3. And what does that look like? It looks like a multiplication, but we don't read it as 2 times 3. We read it as 2 by 3. Let's pause for a quick commercial break.
The Board of Education is responsible for the funding of scholarships, awards, and bursaries within Antigua and Barbuda. In keeping with our mandate, interested individuals who are citizens or nationals of Antigua and Barbuda are invited to apply. Application forms are available online at www.abboardofelucation.com and should be completed and submitted on or before the last working day in April of each year. Scholarships are available for those wishing to pursue an associate's, bachelor's, or master's degree locally, regionally, and internationally. Individuals reading for PhDs are also supported. We are the Board of Education, For more information, visit our website at www.abboardofeducation.com or call us today at 463-9025, 463-9026, 463-9027, or 463-9028.
Welcome back. Now let's take a look at operations in matrices. By performing operations on matrices such as addition, subtraction, multiplication, and so on, we can solve them. The number of rows and columns determine how matrices are calculated. Today, our focus will be on addition, subtraction, and scalar multiplication. The number of rows and columns for each matrix must be the same for addition and subtraction. We pair the terms in the corresponding position as seen on the screen. Now let's apply that process. Matrices are represented by capital letters for quick identity. So instead of reading out the entire matrix, we could simply say matrix A, or matrix B, or matrix C. So here we have three matrices, A, B, and C. For the operations we will look at today, these are the three matrices we will refer to. So let's begin by calculating A plus B. What does it mean? We're literally going to write matrix A, so it's like substitution once again, plus matrix B. And we are going to be adding the terms in the corresponding positions. So in row 1, column 1, we have -2, and we have -4. And so we are going to add -2 plus -4. Moving on to the next position, row 1, column 2, we have 1 and we have -3. So it's 1 plus -3. Second row, first column, we have 4 and 6. And so we have 4 plus 6. And in the final position, row 2, column 2, we have 0 and -1. So we are going to add 0 plus -1. So at this point, we're going to simplify because we have a lot of numbers and we have a lot of signs. And so we want to eliminate the amount of signage that we're seeing in that second part of the equation. So let's begin with -2 plus -4. -2 plus -4. So here we have a plus and a minus, or a plus and a negative coming together, and that simply means to be subtracted. So that could be rewritten as -2 minus 4. Now, -2 minus 4, I'm going to utilize a number line to help us to do this calculation. And so if we have -2 minus 4, it simply means we are going to be starting on the number line at -2. And if we're going to minus 4, it means move to the left 4. So we're going to move to the left 4 places, and that takes us to -6. So -2 plus -4 is equal to -6. And so just as an insert, we're not always going to want to rely on the number line. And so there are some rules of addition that we can also apply here, which is more useful, especially when the numbers or the digits are much larger. And so when we look at -2 minus 4, both those signs are the same. We have two negative numbers. And so the rule says when the signs are the same, you add and keep the sign. And so if I add 2 plus 4, I get 6. And I keep the sign, and so I get negative 6. Let's look at the next part, which is 1 plus negative 3. 1 plus negative 3, we have a similar thing happening here again. And what did we see? When the plus and the minus come together like that, touching each other, this simply means to subtract. And so this can be written or rewritten as 1 minus 3. We're going to utilize the number line again just for practice. And so we will place our dot at 1. And again, when we are subtracting, it simply means to move left. And so we are going to move left 3 places. 1 minus 3. And that gives us negative 2. Now this example gives us or brings us to the next rule of addition. So if we look at 1 minus 3, the 1 is positive, but the 3 is negative. And so the signs are different. And so the rule says when the signs are different, you subtract and keep the sign of the greater. So if I have 1 and I have 3, I can take 1 from 3 and that gives me 2. But 3 is greater than 1 and the 3 is negative, and so my answer is going to be negative. You can even think of this as borrowing. If, for example, you only have $1, can you spend $3? No, you only have $1. And so in order for you to spend $3, it means that you're going to borrow some money. So how much money would you be borrowing? You would borrow $2. And so 1 minus 3 is negative 2. Moving on to 4 plus 6. Now that's simple. Regular addition. 4 plus 6, 10. And again, in our final spot, 0 plus negative 1, where we have those two signs coming together again, and so 0 minus 1 is the same thing as 0 plus negative 1. And once again, if we're at 0, means we're going to take away 1. 0 minus 1 is just negative 1. And that's it for the addition of this problem. Now let's move on to subtraction, because subtraction works just as the addition. And so in this case, we're asked C minus B. What does that equal to? So following the process, we will replace C with the matrix C, and we are going to subtract B. And so B, we have to write the matrix B. And like we did previously, we are going to subtract now the things in similar positions or corresponding positions. And so we have 2 and negative 4. And so that is 2 minus negative 4. You cannot forget the operation. And so 2 minus negative 4. That gives us 2 negative signs coming together there. The next position, we have negative 1, and we're minusing negative 3. And so we have negative 1 minus negative 3. 1 minus 6, 1 minus 6, and then 5 minus negative 1. 5 minus negative 1, and we're going to begin by simplifying from the first position. And so we will start with 2 minus negative 4. 2 minus negative 4. This time we have 2 minus signs coming together, or minus and a negative. They're interchangeable. And so what this means is to add. And so 2 minus negative 4 can be rewritten as 2 plus 4. And we all know 2 plus 4 is 6. And so we insert 6 in our new matrix. Next position, negative 1 minus negative 3. So again, those two signs coming together mean to add, so that can be rewritten as negative 1 plus 3. Now we're going to be utilizing our number line for this problem once again. because now we're adding. And so we're going to begin from -1, and we're going to add 3. So if we're going to add, we move to the right. And so we're going to move to the right 3 places. 1, 2, 3. And that takes us to 2. We can also reapply our knowledge of the rules of addition. So where we have -1 plus 3, the signs are different, and so we will subtract and keep the sign of the greater. So if I have -1 plus 3, I can subtract 1 from 3, that gives me 2, and I'm going to keep the sign of the greater digit, greater value. And 3 is greater than 1, and so 2 is going to be positive. And we don't put the plus sign in front because that's not how we write positive numbers. We just write the number itself. Our third position, 1 minus 6, which is row 2, column 1. So 1 minus 6, again, applying our knowledge of the rules of addition and subtraction, interchangeable. So 1 minus 6, signs are different, and so I'm going to subtract and keep the sign of the greater. So 1 from 6 is 5, and it must be negative because 6 is greater than 1. And so that is -5. And in our final position, row 2, column 2, we have 5 minus -1. 5 minus -1, once again, those two signs coming together mean to add. And so that can be rewritten as 5 plus 1. And 5 plus 1 is 6. Before we take a break, I just want to point out that every single time a matrix is written, it is not a matrix if it is not surrounded or enclosed by squared or curved brackets. And so every step requires us to have our brackets inserted. We'll be right back after a word from our sponsor.
The Board of Education is responsible for the funding of scholarships, awards, and bursaries within Antigua and Barbuda. In keeping with our mandate, interested individuals who are citizens or nationals of Antigua and Barbuda are invited to apply. Application forms are available online at www.abboodoфeducation.com and should be completed and submitted on or before the last working day in April of each year. Scholarships are available for those wishing to pursue an associate's, bachelor's, or master's degree locally, regionally, and internationally. Individuals reading for PhDs are also supported. We are the Board of Education. For more information, visit our website at www.abboodoфeducation.com or call us today at 463-9025, 463-9026, 463-9027, or 463-9028.
Thank you for staying with us. Let's move on to scalar multiplication. When we work with matrices, we refer to real numbers as scalars. The term scalar multiplication refers to the product of a real number and a matrix. In scalar multiplication, each entry in the matrix is multiplied by the given scalar, or in simpler terms, by the number on the outside of the matrix.
So using our three matrices, A, B, and C,
we are now going to calculate -3a. Just like before, it's a matter of substitution. And so we would have to rewrite -3 and replace A with its matrix, -2, 1, 4, 0. Now, the idea of scalar multiplication is that the number on the outside is going to be multiplied to each term on the inside of the matrix. And so we begin with -3 times -2. -3 times -2 is the same as if I used brackets instead of the multiplication sign, because brackets also mean to multiply. And so -3 times -2, and we're going to take -3 and multiply to the next term, which is 1, -3 times 1, and the next term, which is 4, -3 times 4, and the final term, which is 0, -3 times 0. We're going to simplify again, and just a reminder of multiplication and signs. When we have a positive and we multiply it by a positive, our result is positive. When we have a negative and we multiply by a positive, the result is going to be negative. Negative times negative is positive, and positive times negative is negative. So when the signs are different in multiplication between two terms, the result is going to be negative.
When the signs are positive
Between the terms, or in our case, two terms, the signs are the same, the result is going to be positive. So -3 times -2, negative times negative is positive. 3 times 2 is 6. -3 times 1, negative times positive is negative. 3 times 1 is 3, so it's -3. -3 times 4, negative times positive is negative, so our answer is going to be negative there. 3 times 4 is 12, -12. -3 times 0 is simply going to be 0, because there's no such thing as -0. Okay? And that is the end of this particular example. Wasn't that simple? Now let's try another example. This time, we're going to be multiplying a third b, 1/3 of b. So we rewrite the scalar, which is a third, and replace b with its matrix. Like before, we're going to multiply everything in matrix B by 1/3. So 1/3 times -4, 1/3 times -3, 1/3 times 6, and 1/3 times -1. Now let's simplify, but don't get nervous, not because it's fractions, it's actually not so bad. So let's get our reminder, and
we're also going to
consult our side work, and we're going to write 1/3 times -4. And if you notice, it's -4/1, because any whole number can be written as a fraction if we place it over 1. And so we have a fraction times a fraction. So we'd have to remember our rules of multiplying fractions. Can we cancel anything in the direction of the sign? Well, it doesn't make sense to cancel the ones, because it's just going to give you back 1. And we can't cancel anything in that direction. And so this just simply results in 1 times -4, which is -4, and 3 times 1, which is 1. And so that's -4/3. 1/3 of -3, 1/3 times -3 over 1. And so again, we look in the direction of the sign. Can we cancel or simplify anything here? Yes, they're both 3's, and so we would divide both by 3. 3 divided into 3 is 1, and 3 divided into -3 is -1. And so we would have 1 times -1, which is -1, and 1 times 1, and anything over 1 is just that thing, and so it's negative 1. The result is negative 1. 1/3 of 6. Again, we look in the direction of the sign, and we can reduce 3 and 6. What can go into 3 and 6? 3 can go into 3 and 6, and we know 3 into 3 is 1. So 3 into 6 goes 2 times, and so 2 over 1 is just 2. And our final position, 1/3 of negative 1. 1/3 of negative 1, can we simplify, cancel anywhere? No, we can't, right? So we just multiply across the numerator and across the denominator. And so we have 1 times negative 1, which is negative 1, and 3 times 1 is 3, so negative 1/3 is our answer. You'll notice that sometimes we can get portions of our answers as fractions. You may be wondering why in the case of negative 4/3, we left it as an improper fraction. Well, it's quite all right to change them to a mixed number or even a decimal. However, it is the practice when calculating matrices to keep fractions, and even more so in its improper state, as they are simpler to work with as we advance in matrices operations. Let's take a look at our challenge question. Given matrices X, Y, and Z, calculate negative 2/3 Y and X minus 2Z plus Y. We've come to yet at the end of another episode. Thank you so much for tuning in and watching Math Matters. I'm your presenter, Mrs. Tisha Hughes Thornhill. Remember to make your submissions to mathmatters268@gmail.com. Once again, our email address is mathmatters268@gmail.com. We await your responses. And don't forget to join us next week at the same time, where I will be continuing our lesson on matrices.
Ready?